Hi, welcome. In this video, we will solve problem longest common subsequence asked by companies like Apple, Bloomberg, and Adobe.
Now let's solve one more problem where we apply DP on grids. So we are in a series where we are applying DP in grids, basically the 2D arrays. Okay. So now let's solve problem that is on strings. So we are applying DP on strings. Okay. I will tell you how, okay, how the structure will be, and you will get complete whole problem with all the approaches. Okay, just be with me. So let's start. Given two strings text1 and text2, we need to return the length of the longest common subsequence, right? So if you have watched my previous videos, I have clearly declared what is a subsequence. Basically in subsequence, okay, need not to be continuous. It can be continuous or it cannot be, okay, but the order should be maintained. Subsequence should be maintained, okay. So basically if I say A, B, C, D, E, right? A, B, C, D, E. What are the subsequences? A, I have B, A, B, A, B, C, A, B, C, D, right? And I can ignore B, right? So if I am ignoring B, it can be A, C. If I am ignoring C, it can be A, B, D, E. If I am ignoring D, suppose it can be A, B, E, right? And furthermore, right, there will be lots of subsequences, but the goal is you can also ignore the characters. It should here these are basically continuous. These are not continuous, okay, but in order. Okay, so this is all about subsequences, and now we need to find the longest common subsequence. So if I say, right, we have A, B, C, D, E, and we have A, C, E, right? So A is common, right? And then B I can ignore because B is not here. C is common, right? And then D I can ignore here, and E is common, right? So the longest subsequence is of the length of 3, all right? Okay, so this is the problem. I hope you are clear with the problem why we are getting this 3 as an output. Okay, let's take one more example if there is any doubt left. So suppose you have one abc and one string as ace. Let's take the same, right? Still in this case, right, if you can check what are the possible subsequences of abc are, that is a, then ab, then abc, okay, then b, then bc, then c, and we have ac, and we have, I guess, ac only here, as we can ignore b, right? And if I talk about ace, again a, then ac, then ace, then we have C, okay, then we have CE, then we have E, and if I ignore C, it will be AE. So you can find out a common subsequence from all these here, that is AC here and AC here. Okay, so what is the length of this common subsequence? That is 2, and that's why the answer is 2. Clear? Okay. Now let's see how we are going to solve this problem. Okay, again let's take string 1 as A, B, C, and string 2 as A, C, E. Okay, these are the two strings, and we also know what is the answer of these two strings, that is 2. So how we are going to solve this problem, right? What are the possible approaches to solve this problem? So one of the naive approach is that can be possible, okay, that you will generate all the subsequences, you know, right? If you have solved in my subsequence lecture, you know, like what how many subsequences will generate? It's basically 2 power 3, okay. Because 3 length is 3, so it will be 2 power 3. If you can remember, the time complexity was 2 power n. Similarly here it will be 2 power 3 because of length of 3, so 2 power 3 will be generated, 2 power 3 will be generated, that is 8, that is 8. And what you will do, you will try each subsequence, right? You will try each character from here, you will check is it equal or not, and then you will return the answer. Yes, one of the way, right? So here you will get 8 subsequences. Here you will get 8 subsequences. Okay, so then you will basically 2 power 3 into 2 power 3, and you will multiply. Why I'm saying multiply? Because this is of generation. This you will generate, and then you will check each one of the subsequence, is it equal or not? Okay, and then it will be your answer. Okay, so the time complexity will be same, right? Will be this one, 2 power 3 into 2 power 3, that is the length. If I say 2 power n into, suppose the length is m, so 2 power n into 2 power m. Okay, so we are going to apply the same method, right? Because in subsequences we need to find these thing, right? But not in this way, that we are generating and we are collecting all the subsequences, then we are generating and collecting all the subsequences. Because in order of that, we need to use the space as well as 2 power 3, right? We need to use the space, because whatever the strings will be, 8 subsequences will be generated. So I will store the 8 subsequences in an array. I will store these 8 subsequences in an array, right? And then I will compare. So it will take a bit amount of time, right? And like time and space will also be there. We will try to find a more convenient way how we can solve this. So let's see, right, what how we can solve it. Let's try to define a bit more structured approach. So again, we have two string str1 as a b c, and we have an string str2 as a c e. So what I will do, okay, what I will do, I will create, I will we will use recurrence relationship. Okay, recurrence. So basically we will apply recursion. How? See, the problem is we need to find the longest common sequence here, right, in ABC and AC. Okay. So what I will do, I will solve for the very one part, right? Not, let's think about the whole complete part. Let's solve for the very one part, that is ABC and ACE, right? So I am at here, I am at here, right? And I am comparing, and I am simply ignoring the rest. I don't know about what is the rest. Okay, I will call for the other, but I will just checking, is C and E both are equal or not. Okay, I'm just checking this one. Okay, then I will solve. So basically you can see my one pointer can independently, my this pointer can independently move, right? It's not a relation with this one. And one my pointer, this can also independently move. Okay, when I'm saying independently, that means I don't need to do same, like this pointer should be me. Suppose this pointer is I, this pointer is J. I don't need to mm, say that I will also move here with the same as J. No, I can move alone, complete the string. J can move alone, complete in the string. All right. So my function, okay, my function, let's name the longest common subsequence. So LCS function will have I comma J, and where I is representing the last point, the last, remember the last index 0, 1, 2, the last index of the string. So where I can mention, let me put it here. So where I is basically the string 1 dot length minus 1, and J is basically the string 2 dot length minus 1. Basically they are pointing to the last index. They are pointing to the last index. So that's a different case. Okay, when we have two not characters that are equal, right? When we have no, these characters are not equal. Okay, so before going to this not equal, I will come later. Let's solve for the character that are equal. So I will just copy this whole, and let's solve for if the characters are equal. Okay, then you will eventually get the case of not equals. So here we have ABC, and here we have AC. So let's change our string, I guess, and that will help in all the directions. So let's take one string where we have, you can take as, what should be the string, that is suppose ABC, and we have suppose BAC. Okay, ABC and BAC. Okay, and let me put the indexes 0, 1, 2, 0, 1, 2. Okay, so you can see my I pointer is pointing to this one. and my j pointer is pointing to this. So now when the characters are equal, right? C is equals to C, right? When I is the when string one of I is equals to string one of j, can I say that is count as a one length? Yes, that can be count as a one length. So what I will do when these string characters are equal, okay, basically when str1, okay, str equal when str1 of I is equals to str2 of j, what I will do in this case I will say that I have find out the one. Now do for the rest of the string, that is LCS. Okay, do the rest of the string, that is I minus 1 comma j minus 1. Okay, I am writing this one. Remember, basically what I am saying, I have found that these are equal, so I am counting their length as 1, and I am finding the longest common sequence for the other part. AB. I'm finding the common subsequence for the other part AB. Okay, here we have BA and AB, so I am finding the longest common subsequence for the other part. Okay, so basically how it works, we have ABC, right, and BAC. Okay, here I found both the characters are equal, right? So my answer will be basically 1 plus 1 plus the rest of the part, that was AB and now BA. Okay, and now let's solve this example only. I guess this is the good one. So we can solve this one. AB and BA. Now we need to find A, B and B, and now you can see the case that we were discussing about when the characters are not equal. Okay, B and A are not equal. So now there are, if you can look closely, there are two possibilities, right? Because see, eventually we are getting an answer one here from here, right? So one case can be, you can either, because subsequences of ignoring the character, so one case can be you can ignore this character, right? Suppose the ith character, so if I am ignoring, it will be A, then BA. Or one case can be you can ignore this character A, right? So if you are ignoring these from second string, it will be AB and B. Okay, and now you are again judging, is it equal, is it equal, right? So basically you are judging from here, so now let's see. So we are getting here both are equal. Yes, whenever there is an equal, the answer will be 1 plus, and I need to find out the character on this will be become empty, because if I do I minus 1, this will become empty, right? And this will become B. Okay, same answer for this one, right? Characters are equal, I will do 1 plus, there will be A, and this will become empty string. Now see this case, right? See this case. When we have an empty string, I'm saying, I have one string that is empty, and I am comparing one string, one and string two, that is B. Empty string, it's a subsequence, okay. B. Both are not equal, right? Can I say when I am getting an empty string, can I directly say that it can't be equal? It can't be equal, because we are not considering, right? If they are an empty string, they are also empty string, we are not counting this case as one. No. Okay, we should be, there should be some characters. So if there is an empty string, can I say the answer will definitely will be 0? Why? Because that's an empty string. It's an empty string, right? It's an empty, there is nothing. So how you will get any common thing, because when there is nothing. Okay, so the answer for this one will be 0. Okay, 0. Okay, this 0 here, the answer will be 0. 0 plus 1 will be 1, so basically it will return 1 here, and it will return this one also return 1. Okay, now what you need to do, you need to take max of it, right? You need to, either this can be true or this can be true, right? Any of the condition, basically. Suppose here the both the cases you are getting 1, but suppose in one of the case where maybe you are getting an answer in one of the path. Okay, we will discuss the next case in the last scenario. uh, when we getting one of the common paths, so what I will do, I will take max of it. So from both we are getting one, so I will take any one of them and I will get 1. So basically I need to take max of, that is 1 coming and 1 coming from here. So it will be 1 and 1 plus 1, it will basically return 2, and the answer will be 2 for this one. Clear? Okay, now let's get back to our previous uh, example that we were trying. So basically how we can solve this again. Now we understood when the characters are not equal, then how it works. So let's see, let's solve this one. So I have one a b c and we have one a c e, right? And the characters are not equal. So I have two cases. One case is when I will ignore one character from the string 1 and I will take ace. One case when we ignore the character from the second string, we have AC, and I will take the max of it. Again, the characters are not equal. So what I will do, I will ignore one character from the my one string, and I will say ACE. Okay. One case when I will ignore the character from the second string, and it will be AC. Now again, both are not equal, right? So what I will do, I will ignore one character from the first. It will be an empty string ACE. And if I am ignoring from one character from here, it will be A, then AC, right? Because you are ignoring E. Now if I continue this one, right? This will be an empty string. Ignoring one character from string 1, it will be AC. If you are doing this one, so it will be A and A. Okay, now A and A, that's a case of, okay, so let's solve this one first because we are solving left. Okay, so let's solve this one. That's an empty string, so the answer will be 0 here. Okay, now let's solve this one. Here we have both the string A, so I will solve 1 plus, and both the characters will be an empty string. Why? Because one shift, remember, I minus 1 j minus 1, I minus 1 j minus 1, right? So one shift from both of it, right? So it will be an empty, right? So the answer will be here 1. So 0 from here, 1 from here, right? What is the max of it? What is the max of it? 0 or 1? 1. So 1 will be the answer here. From here, I will get 0, right? So 0 the answer from here. What will be the max of it? That is 1. So 1 will be returned here. Okay, now this case is not explored. Now let's explore this one. If you are ignoring one character from here, it will be A, then AC. If you are ignoring one character from the second string, it will be AB and A, right? If you are ignoring first character, it will be empty string and AC. If you are storing one character, that it will be A and A. Okay, now here as well, right? If you are ignoring one, it will be A and A. If you are ignoring from the second, it will be AB and empty string. So we have checked when the characters are equal directly. Can I say 1 because there is nothing left and I want some space? I'm not applying the function call, but yeah, the answer will be 1, A and A, and then it will be an empty string, right? Basically 1 plus an empty string case. So this will return 1. This will return 0 because an empty string, right? So 1 plus 1 and 0, what will be the max of it? That is 1. Here A and A, right? This will return 1. This will return 0. What is the max of it? That is 1. Now what is the max of these two? So the answer will be 1, and that is true, right? In AB and AC, 1 will be the answer for sure, right? So if you are ignoring one character from first or one character from the second, you are going to get one answer, right? So 1 from here. Okay, now 1 from here, 1 from here, the answer will be basically 1. Okay, and now we will see. So you can see here we should get an answer of 2, right? The answer will be ABC and AC. We will get 2. Let's explore this one, this case. So if I'm ignoring the one character from the first, it will be AB, right? And if I'm ignoring one character from here, it will be ABC. Sorry, ABC and is A. Okay, so it will be AB and AC. Now AB and AC, we know the case, right? So I'm directly writing, otherwise this tree will be happen here. So I'm directly writing the case. We know that AB and AC will is going to give 1 as a solution. So I'm writing this directly as 1 because of this one. Okay. Now in ABC and A, right, what will be the answer? Let's see. Where I have ignored C. So here we just left, I guess, C. It should be C because you are uh, in here you are ignoring first character from here, and in this case, yes, I guess the first character from here as well. So it will be A. So I missed one thing, right? And that should not this case. Why is it not this case? See, both characters are equal. C and C are equal. So that's a case when we will do 1 plus I minus 1 and j minus 1. So what I will do, I will simply say 1 plus, and we have AB and both are left A, right? AB and A case, right? So do we have solved AB and A case? Yes, we have solved this case AB and A, right? What is the answer of AB and A? That is 1. Okay. So here 1 plus 1 will give me 2, right? Now from one side we are getting 1, from second side we are getting 2, right? And what will be the max of it? That is 2, and the answer will be 2 here. The answer will be 2 here. Okay, and that's we are getting an answer of 2. So basically this will be our approach to, right? And I hope you are clear with it. If I am going to write pseudocode, let's quickly write the pseudocode. Now you are very clear of it. So let's go ahead to the write the pseudocode. So what will be the pseudocode? So we have one function LCS, okay, longest common subsequence, and we are passing I and j only. That is my string 1 and string 2 last character. Okay, so I have an string 1, let's suppose again ABC, and ACE, string 2 as ACE. Okay, so in this case, okay, what was the base condition? If you can check, the base condition was whenever we are getting an empty string, any one of that, right? Either I pointing to empty or j pointing to empty, I will return 0, right? So I can write the base case. If my I is less than 0 or my j pointer is less than 0, simply return 0. Okay. Second case, if both are equal, remember the equal case. So if string 1 of I is equals to string 2 of j, what should I do? If both are equal, then I can simply return 1 plus again the same function called LCS of I minus 1 comma j minus 1. Okay. Else case, if they are not equal, in that case, okay, in that case I will simply return that max of it, right? So it will be basically 0 plus method dot max, or simply max, you can, or let's say method dot max of both the cases, right? So both the cases means the one LCS will be of I minus 1 comma j, and one LCS of I comma j minus 1, right? Whatever the maximum I am getting, I will return this thing. Okay, and that's it. That's your LCS code. And in the last, basically you need to return, if suppose it's of n length and it's of m length, so you will return, or you will call your LCS function, whatever you can call it, LCS with n minus 1 m minus 1. Okay, and let not put this n and m because we'll use the structure. This is m, this is n. So what I will do, I will say m minus 1 and n minus 1. I will tell you why I have done this m and n. Okay, just for because few problems I have solved with, I am taking m as rows and n columns, so I am prefer with this one. Okay, so yeah, this will be our pseudo code. And if I talk about the time complexity, so let's quickly talk about the time complexity. So basically, in a string of n, you are exploring all the subsequences, and in string of m size, you are exploring all the subsequences. So it will be 2 power n, 2 power n into 2 power m, right? So you can see this from your recursion tree, right? See, I am getting two cases, then I am getting two cases in each string, right? Even in this case, right, with the AC, we will go, even we have single character A, right? We'll go with the all the possible, right? This one, all the possible subsequences, right? Either this character or this character. So 2 power n into 2 power m, This will be the time complexity. What will be the space complexity? Okay, so space complexity, it's we are not taking any extra space, but there will be a recursion stack memory. Okay, and recursion stack, right? So we have a string 1 of size n, we have a string 2 of size m. So if you can check, right, any tree, right, any tree, if you want to check, um, basically here you can see, or let me take one case where we have, suppose we have AC CB, right? So this is of size 2, this is of size 2 CB, right? So again you will explore one of the path, you will explore one of the path with A CB, and you will explore this one path, right? The recursion path that will be with CB, right? Then you will explore CB, right? It can be, there can be, if suppose A then CB, okay, then if that's an empty, it will be CB, then you will explore this one also, right? uh, where you are ignoring C and then you are ignoring B. So if you are taking count of one path, right? So one path, then second path, then third path, right? So basically you are taking this length and this length in your recursion stack. In your recursion stack, you will take this length and this length. So the size will be big O of n, space complexity will be big O of n plus big O of m. Okay, because see, this is of n path and this is of n length and this is of m length. But in recursion stack, when you will create a tree, right, here you can understand with this one where we have created a tree. Yes, this one. You can see even it was 3 and 3, we are exploring all the path, right? Even with this one, see, we are exploring this one. So here we have only one character, here we have three character. So I am exploring this path AC, then it will become A, right? So this will take three times, basically three path, three iterations, and this from ABC to we have reached here, right? This is also taking three. So you can see to solve one problem, we are going till this length and this length, right? That's why it is big of n plus m. So that's the space complexity of our recursion stack. Now this is very high time complexity, 2 into n, 2 into m. So there will be, you can see there are repetition of function calls where we have checked this. Yeah, I guess in this case you can see I'm calling this function a, b, and a, right? And this function is called it here as well, right? So why I need to explore this path? Okay, you can see I have I am getting this a comma a as an answer of 1, right? So why we should explore this path a comma a? So there are same function calls here. They are same function calls here. Whenever there are same function calls, we can store these values. Basically, we can store these values in an DP and we can directly give the answer. Like how I got the answer, right? When I called this a b comma a, I have checked like did I solved a b comma a? Yes, I have solved. I have directly put the answer 1. I have not explored this path. So for this, what we will do, we will apply DP, right? And there is nothing needs to be done in DP, right? It's all about recursion. Okay, we will simply applying DP without any tensions and stress. Basically here we have one pointer I, right, and one pointer is j. I can independently go till length n, j can independently go till length m, right? So what we will do, we will simply apply dp of 2d array, right, which the size will be of m, okay, and n, where m is the size of first string and n is the size of string. We will apply this one. Okay, so if I'm applying dp here, okay, in the same code we will apply dp. Okay, so let's quickly copy this code and apply the dp solution. So if I'm applying dp, what are the things I need to change? Okay, very few things. Okay, I want return from here. Okay, I will return the dp. So basically I will say dp of I comma j here equals to 1 plus LCS. Here also I will say dp of I comma j equals to 0 plus LCS, and I will say return dp of I comma j, that will be an answer. And what I will do, if I is less than 0, j is less than 0, I will return 0. But suppose doing any further calls, I will say if my answer is in the dp, that means dp of I comma j, it's not equals to minus 1, not equals to minus 1, simply return the dpieg. No need to do the function calls. Okay, we'll simply do the dp of ij, and in the starting of this function call I can assign a dp with a 2D array, okay, of size m and n, right? So it will be a size of m and n, and we can apply dp here. So that is your dp solutions. When you have done the dp solution, now what will be the time complexity after applying dp solution? So you are exploring here n and m, right? uh, Basically ABC and AC, you are exploring all these options, right? You are not calling two functions again and again. Okay, so the time complexity will be n into m. Okay, and the space complexity will be one of the dp, that is big O of n cross m, basically, or m cross n again. Why, I guess I should do n cross n. So m cross n basically, and m cross n, what is this m cross n? This is of your dp size. Okay, now dp size, and what will be your recursion size? Okay, recursion will also have some memory. So yes, it will have the same memory that we have discussed, that was big O of m plus n, right? Because you need to explore one path, right? One path you need to explore, because to store in the DP. Once you have stored, then the remaining function calls you can directly say, but one path you need to explore. So this time and space complexity will be big O of m cross n and m cross n, big O of m plus n for the DP. This solution is for when you are applying DP. Now, when we have discussed DP, right? Now let's quickly discuss the tabulation solution, right? What is this tabulation? Okay, you can say this tabulation, it's bottom up approach. So what is this bottom up approach? Okay, so bottom up approach means, right, where we are applying DP. Now you are applying DP here. Can't we use the same DP to find out the solutions? Okay, basically not that bottom up approach. Bottom up approach means, see, from we are solving this from top down, right? From top down we are at C, right? We are comparing and we are going to the zero end. No. Bottom up approach means we have the solution of the base case. We have the solution of the base case, and from base case we are reaching to the end. Okay, so what is the base case? Now here base case is a bit different. Let's quickly understand how we will apply the tabulation. Okay, let's take the same string ABC and we have ACE. Okay, so we have a base case when I is less than 0 or j is less than 0. What I will say? I will say return, in that case, 0. You need to return 0 in that case. But can I apply that in DP? Because how will I apply? I is less than 0, that means DP of minus 1. DP of minus 1, no. This you can't apply in a 2D array something as minus 1 as an index. Okay. So you can't apply minus 1 as an index. So you need to shift index. Okay. We need to shift index. So what I want minus 1. Okay. But I can't do it. The only indexes I am getting, I can get 0, 1, 2, 3, and up to m minus 1. Okay, if I'm talking about the string 1. So what we will do, we will shift indexes. We will shift indexes. So my 0 will represent minus 1, my 1 will represent 0, right? My 2 will represent 1, and my m minus 1 will represent m minus 2. That means m will represent m minus 1. Okay, so basically my answer will be at around m. So we will take dp from 0 to m size, right? Because for minus 1 we need to put 0. All right, so let's take dp here, of size, this is of size m. Okay, string 1, string 2 of size n. Okay, and now let me quickly create a dp grid. So this is my DP, right? And remember, you can, like, whenever there is a tabulation, whenever you need to write the code for tabulation, that can be directly done by our that DP solutions, because we are, how we get the approach of DP, because we are taking an space of 0, right? So now you can see the size is m and n, right, of a string, and we will use -1 indication as 0, right? So I want a size of m plus 1. Okay, my size of the DP will be m plus 1 and n plus 1. Remember why? Because the 0 will point to -1 and my m minus 1 will be represented by m. So I want an size of m plus 1. Okay, so basically this is the size of m plus 1 into n plus 1, n plus 1, right? So here you can see we have 3 length, right? So I will say 0 1 2 3, right? It should be 2, but because we have m plus 1, that's why 0 1 2 3, right? And now see, now we will fill that case that we were discussing about. If I is less than 0 and j is less than 0, we need to return 0, right? So if I is less than 0, my that is a -1 case when I will be at -1. Okay, so -1 case I am representing with 0, so I will fill all this with 0. Okay, means, see, what this 0 is, basically these are I comma j. So when I is pointing to 0, I will fill all the 0. When j is pointing to 0, I will fill 0. Basically, understand this thing as a -1 case, right? This is the -1 representation. -1 0 1 2, like this one. Okay, so I will fill with 0 and 0. Now see, remember this thing, right? You have I pointer and j pointer. Okay, and now you need to fill the DP. So now let's quickly add the things exactly as we have discussed there. This was our solution, right? So let's put the same iteration. Okay, exactly same iteration, no need to do any change. So what I will do, let's take that in a new page here. That was our DP solution, and that is my tabulation. So let's put this here. Okay, I can remove these extra, this extra, this extra, this extra. Okay, let me write m plus 1, because this will remind you that this is a size of m plus 1 and n plus 1, and we have, remember this, we have I and j. I is pointing to 0, j is pointing to 0, right? So whenever the string are equal, right, whenever the string is equal, dp of ij will be 1 plus lcs of I minus 1 and j minus 1. So what you can do, you can simply change your relation to, whenever the strings are equal, whenever the strings are equal, dp of I comma j will be 1 plus dp of I minus 1 comma j minus 1, right? Now see, lcs I'm representing with dp. Now else case, not equal case, not equal case, that math.max of lcs I minus 1 j, I comma j minus 1. So I will say dp of I comma j will be max of math.max, basically dp of I comma j minus 1, or dp of I minus 1 comma j. This will be my equal case, this will be my not equal case. And the base condition we have already filled. This condition we have already filled, that, right, 0 will be represented by 0. Let's quickly understand this by taking example. I have one string 1, that is of, again, abc. I have string 2, let's take string 2 as a c e, right? And now let's apply. So 0 1 2, 0 1 2, I pointer is here, j pointer is here, both are at 0. Okay, so basically when I'm saying I at 0, right, remember your I should be at 1, because see, if I is pointing to 0, that means in my DP the position will be 1, right? So here now I will be start from here and j will start from here. Okay, first character you can assume. So we have a and a both are equal, right? So let me put it like this, so you will get it more clear, that here we have A, B, C, and here we have A, C, E. Okay. And now let's start filling it. So when we have A and A both are equal, right? Equal case, that 1 plus dp of I minus 1 and j minus 1. So what is I minus 1 and j minus 1? That is 0. So 1 plus 0, that will be 1. So this will be filled with 1. Now let's fill when we have an A and C. Okay, not equal character. So either I can go I j minus 1. So if I'm going I j minus 1, that means this 0, or I minus 1 comma j, that means 0. So maximum of these two, what is the value? That is 0. So here we will get 0, right? Again for this case, A and E are not equal. So maximum of 0, right? 0 and this case, remember this case, see I minus 1 comma j, I j minus 1, so this will be 0. Okay, now here we have B and A, both are not equal, so maximum of 1 and 0, which is 1 only, right? So this is filled. Now again I am at here where we have B and C, both are not equal, so maximum of I j minus 1, that is 1, and I minus 1 comma j, maximum of this one and 0, that is 1. Then here B and E both are not equal, so maximum of 1 and 0, that will be 1, right? Here C and A both are not equal, so maximum of 0 and 1 will be 1. C and C both are equal now, both are equal, so maximum not maximum, 1 plus dp of I minus 1 and j minus 1. So 1 plus of I minus 1 and j minus 1 is this one. See I and j are here, I minus 1 j minus 1 this one, so it will become 2. Okay, now C and E both are not equal. C and E both are not equal. So maximum of 2 and 1, that is 2. And that is my last field. And my answer will be dp of M comma dp of N. And that is 2. Okay, so here in the last you will return dp of M comma N. Right, same tabulation method, right? So now you got it. Basically, we will run iterations for loop from starting from 0 to n and 0 to m. So let me quickly write the pseudo code for the tabulation. Okay. Um, if I am going to write tabulation case, so what we will do, we will take a dp 2d dp 2d array of size m plus 1 and n plus 1. Okay. Now I will make all my zeroth row and zeroth column as 0. So I will say for I will start from 0, I will go till m. Okay, now remember it will go till m plus 1. Okay, and what I will do, I will say dp of I comma 0 will be 0. Similarly, I will run a loop that will start from 0 to n plus 1, and I will say dp of now zeroth column, right? Zeroth row and all the columns. So I will say j will be 0. Now what I will do, I will run a loop that will start from 1 because 0 0 is done. So that will start from 1. It will go till less than equals to m and I plus plus. Similarly, I will start a loop that will start from j equals to 1 and j will go till less than equals to m, m, n and j plus plus. Okay, now here what we will do, exactly the same logic that we have used. Okay, that means if it is a equal case, if it is a equal case, what I will do, I will say dp of ij will be 1 plus dp of I minus 1 and j minus 1 if it is a equal case. So now what will be the equal case? Basically how you will check, you will check if basically your string 1 I is equals to I comma j, so you will do I minus 1. Remember, one index left will represent 1. String 2 will be j minus 1. Why I'm doing this I minus 1 j minus 1? Remember, here I have 1, but that 1 is representing 0 here. Here I have j as 1, but that j is representing 0 here. Remember a and a. So we will do I minus 1 and j minus 1. Equal case, not equal case, we can simply put else and we will get this in an answer. After this all thing, we need to represent, put dp of m and n, right? Now, after applying this, what will the time complexity, right? So this is running for m times, this is running for n times, this is running for m cross n times. I will say m plus 1 cross n time, but it is running from 1 to m. So that is m and n only. Okay. So the time complexity, because I will take the maximum of it, so it will be big of m cross n. Okay, space complexity will be big of m cross n, no any space from the recursion because we are not applying recursion. So that will be the time complexity and space complexity. Okay, now as we do, basically you know that we also do space optimization, so I am leaving that to you. Can you further optimize that space? Remember that we are, can we use the same row, right? Can we use the same row or same column? That's a hint, right? Can we use the same row and same column to get the answer? We don't need to create the dp. So if I talk about any cell, right? If I talk about any cell, let's take this cell. So this solution can be depend on this one, okay? Because if the characters are equal, or can be depend on the maximum of this one. Okay, we don't need to use any this these kits. We can use only the last row or the last column, okay, for this answer. So see how we can solve this question by we can how we can further optimize it, okay? But that's the tabulation technique and the df what we have lcs basically, the recursion technique. Okay, so we have applied the whole things. Okay, now in the next video I will show you a code implementation of both the approaches of tabulation and the dp solutions. Okay, and after that we are good to go. I guess there is no need of dry run, but when I will write the code, I will get, if there is a need, I will surely put a video of dry run also. Okay, that's all for this video. See you in the code implementation part. So you can jump to the code implementation part now.